Welcome to The Explainer. Have you ever stopped to wonder how a video shot just moments ago in California can play instantly on your phone in, say, Tokyo? Well, today we're going to pull back the curtain on the invisible network that makes the global internet feel like it's right next door. It's this hidden technology that's absolutely essential for pretty much everything you do online.
All right, here's our game plan. First, we're going to tackle the internet's biggest headache, its speed problem. Then, we'll meet the hero of our story, the CDN, and see how it uses some clever routing and caching to work its magic. And finally, we'll wrap up with why this all really matters. Let's dive in.
Okay, first up, the internet's speed problem. And at its heart, this is really just a story about distance, plain and simple.
Oh, we've all been there, right? You click, you wait, you give up. But that frustration, it's not just you being impatient. It's a direct result of a fundamental law of physics. The speed of light is the absolute speed limit in the universe, and that cosmic speed limit has a huge impact on our digital lives.
So get this, for a video to get from a server sitting in New York to your screen in Paris, that data has to physically travel across the Atlantic Ocean. That journey, even moving at the speed of light through fiber optic cables, creates a delay. We call that delay latency. And the rule is simple. The more distance you have, the more latency you get, and that means a slower, more frustrating experience for you. So how in the world do we solve this problem of distance? Well, let's meet the internet's very own express delivery service, the Content Delivery Network, or what everyone calls a CDN. To put it simply, a CDN is basically a global team of servers. Instead of having one single server somewhere trying to handle requests from the entire planet, a CDN is way smarter. It places copies of websites and videos on servers all over the world. And the goal? It's to drastically shrink the distance between you and the stuff you want to see. And this right here is the key idea. Every website has an origin server. You can think of that as its home base, where the original master copy of everything lives. A CDN then surrounds that origin with a whole network of edge servers. These are the servers placed in all those strategic spots around the globe, in places we call points of presence, or POPs. So if the origin server is the main factory, the edge servers are the local warehouses that get the product way closer to you. All right, so that brings up a good question. How does your computer know to grab the video from the nearby warehouse in Paris instead of going all the way back to the factory in New York? This is where the CDN's intelligence really kicks in. Let's just trace the journey of your click for a second. The whole thing happens in the blink of an eye. It starts when you make a request. The CDN system instantly intercepts that request, and instead of letting it travel thousands of miles, it intelligently steers it to the closest edge server. That server gets the request, we call that a hit, and bam, the content is delivered to you right away. It's unbelievably fast and efficient. Now, this routing isn't just magic. It's some seriously smart technology at work. They use techniques like Anycast, where tons of servers can share one IP address, and the network automatically figures out the fastest route for you. Or they use GeoIP, which literally looks at your location on a map and sends you to the server that's physically closest. It's all about finding the absolute path of least resistance for your data. Okay, so your request gets to a nearby server. But how does that server already have the video you want? The secret ingredient that makes this whole system pop is something called caching. Caching is a really simple idea. It just means storing a temporary copy of a file somewhere close by. The edge server saves copies of things like images, videos, and all the code that makes a website work. That way, the next time someone in that area wants that same file, the server doesn't have to go all the way back to the origin. It's already there, in the local cache, ready to go. And there are basically two main ways CDNs do this. With a pull CDN, the very first person in Paris to ask for that video from New York pulls it across the ocean. The Paris edge server then saves a copy, caches it, for every single person who asks for it after that. Then you have a push CDN. This is where a website owner knows something is going to be huge, like a big movie trailer dropping on release day. So they push that file out to all the edge servers ahead of time. It's preloaded, just waiting for that first click. But hang on, what happens if a website gets updated? You don't want to be served old, stale content, right? To solve this, every file stored in a cache comes with an expiration date. It's called a time to live, or TTL. As soon as that timer runs out, the edge server knows, okay, time to check back with the origin server and see if there's a newer version. Okay, So we've seen how it all works, but what's the real payoff? Now we get to the big so what. Let's look at the real-world benefits, not just for you, but for the entire internet. Honestly, the impact is massive. For us, the biggest win is just faster websites, less waiting around. For website owners, it means better performance, since their main server isn't getting hammered with every single request. It also means incredible reliability. If one edge server goes down, another one just seamlessly takes over. CDNs also give sites the power to scale up and handle huge spikes in traffic. And they even add a powerful layer of security, protecting sites from nasty attacks. So here's the bottom line. The next time a web page just snaps onto your screen or a high-def movie streams without a single hiccup, you can thank the silent, invisible work of a CDN. It is the essential backbone that makes the fast, reliable web we all pretty much take for granted possible. It really makes you think, doesn't it? We've just peeked behind one of the curtains. What other incredible, invisible systems, what other hidden layers of architecture are quietly working in the background right now to power our digital world?